Okay, hello everyone. We are working on our Unit 6, Lesson 6 on multiplying radical expressions. That's your title for today's notes. So go ahead and pause the video and write that down. Again, multiplying radical expressions. So you don't have to write this down, but just know by the end of the video, you should be able to multiply algebraic expressions involving radicals whose radicands are monomials. Okay, monomials. That's a lot of vocabulary. So let's talk about what radicals mean. Radicals mean square roots, cube roots, fourth root, any root, okay? And radicands mean what is underneath. So I would tell you to write this vocabulary down. Radicands mean what is underneath the radical sign. And then remember, monomial, we talked about that at the beginning of the year. Monomial means one term. And that is a polynomial vocabulary word. Right, so go ahead and pause the video and write that stuff down because that is a lot of vocabulary. So let's do a review on multiplying using the laws of exponents because that's going to come very in handy when we're dealing with radical expressions if you haven't noticed from the previous videos with us having to break down the square roots and simplify, so they're going to come in handy. So you need to write this one down. It's called product rule. You should be familiar with this. You probably have already written it down in the first video, but write it again. So it says if you have the same base and they're raised to an exponent and you're trying to multiply those two things, you would add the exponents. Okay, so go ahead and write that down as a review, even if you wrote it already. You can never write it enough. Okay, so let's use what we were just talking about in this previous slide as a review to kind of do a couple that is not involving the radicals so that you kind of get the hang of what you do when you see them. So again, remember product rule. I'm going to rewrite it for me at the top because, just to have in memory, is that when I'm trying to multiply things of the same base, or even just two monomials, because in this case we have two monomials here, I'm trying to multiply them. What I do to the exponents is I add them. So let's work this out together as a sort of review. So what I like to do is I like to do numbers first. And then I tackle letters. And I go in order of the letters, but sometimes you have more than one. So I'm going to do X first, then Y, and then Z. Okay, so I'm going to break it down. And here's where my handy dandy color is going to come in. So, grab your colors. Okay, so I'm going to do the numbers first, which are 6 and 8. And we should know that 6 times 8 is 48, unless we cannot do mental math. Get that calculator. Okay, so 6 times 8 is 48. And then I'm going to do my letters. Again, remember I said I'm going to go in order. So I have my X term that I'm going to do together. X squared times X to the 7 means to add the two exponents. So that's 9. Okay. Now I'm going to do my Y's. This is why I like to break it up because sometimes it's a lot, y'all. And that's why I like to do pieces, piece by piece. So again, my two Y terms being multiplied by each other means to add the two exponents. 4 plus 3 is 7. But let's look at our Z. So if we look at our Z, we have Z times Z to the 5th. Please remind yourself that there's an imaginary 1 there. And so I'm going to do 1 plus 5, which is 6. Okay, so my final answer for this, with all of my colorful pieces added to it, is 48 X to the 9th, Y to the 7th, and Z to the 6th. Okay, sometimes I like to also write that slash Z so that I don't get confused if that is a Z and not a 2. Okay, so that's a little bit of a review. Let's do one more. Pause the video if you need to. Alright, so let's do this one with some fractions because I know, oh my god, fractions, we get so scared. But they're not scared of us. They're friendly. Okay, so we're going to do our numbers first. Negative 11 times 2, which is negative 22. This is a listening check. This is a listening check. Please draw a ribbon, because it is Red Ribbon Week. week. Did y'all know that? I don't know. Draw a ribbon and color it red. That's a listening check. Okay, so let's continue with the problem. So now we're going to do the variables, the letters. So let's do our two x terms together. Okay, and then remember when you are multiplying with the same base, you're going to add the fractions, and they just so happen to have the same denominator, so you're in luck. 2 plus 4 is 6, and then 6 divided by 3 is 2. Again, if y'all don't know that mathematical, make it a calculator. I'm not going to be mad at you. Alright, now let's do our y terms. Again, yay, they have the same denominator. So we just add the numerator, and that's 2/3. So now let's put everybody together. Y'all don't probably know that song, y'all. I'm confused. Okay, so let's put everybody together. Now, here's a little conversation I wanted to have. That's why I threw this one in here. And it's because we have been practicing rewriting, hopefully by now, maybe not on how to do video, how to rewrite this right here. And so remember that this is your index, okay? And this is your exponents. So when I get ready to rewrite this right here, the index is 3 and my exponent is 2. Okay, so that's another way to write this answer that will be equivalence. Let's see if I can spell that. I teach math. English. Look at me. Equivalence. Okay? Equivalence. So that's a little bit of review, and that's going to lead us to what we about to really do. Because if y'all thought this was simple, let's see. So again, I was just doing this in the last slide, so you need to pause the video and rewrite this down. That's what we just did at the end when we had created that equivalent equation right here, where we wrote the index and then the exponent. That's what this is. So pause the video if you need to, because you need to know the difference between rational exponent form and radical form. Hint, hint on the test. All right, so let's talk about these steps, because we did a little bit of practice, but we didn't really get in there. So here are the steps. Again, pause the video if you need to. So when you're multiplying radical expressions, you first want to multiply them if they have the same root index. Meaning if that index is not the same, we cannot be sitting here trying to multiply them, okay? Because they are not the same index. That's what we need to check for first. And then remember, when you have a square root, its index is a 2. It may not be a number there, but there's an imaginary 2. Next, you're going to multiply the number that's outside the radical sign, which is known as the coefficient, okay? And we always do our numbers on the outside first. And then third, multiply the numbers under the radical sign, which is also known as the radicand. We wrote this down earlier in the video. So, I like my little anchor charts, so write down again. And then last, simplify. We've been working on that, breaking that down. So let's get into some actual problems. I'm tired of looking at steps. If you're not tired of looking at them yet, pause the video. This is a listening check. This is a listening check. Go ahead and draw a pumpkin and color it orange, because y'all know what season we in. We are in Halloween season. Well, actually, by the time you watch this video, we may not be. If y'all kind of look at the desktop, I'm recording this on the 24th. So we still in Halloween season. All right, so let's do this first one together, y'all. So we're going to follow our steps that we have always been trying to follow, which means, do they have the same index? Yes, they're both square roots. So I can say check to the same index. Boom. Next, we are needing to multiply the numbers that's outside of the radical. So that's that 2 and that 4. What's 2 times 4, y'all? I hope y'all know. 8. 8. Our next step, okay, says to multiply the numbers underneath the radical sign. So let's do that. That's 12 and that's 15. That's kind of big. Y'all might need that calculator, but I don't really need a calculator. I can do some mental math. 180. All right, 180. And now we're gonna put our pieces together, because what did our last step say to do? Let's go back. I don't have my steps memorized yet. It's Cooper. Our last step said to simplify. This is not simplified yet because 180 can be broken down. Here comes them perfect squares that honestly you should have these memorized by now. So if you don't, I'm going to need you to go back and write them down again. I'm not going to write them all down. What I'm going to write down is all the ones that I need to do to get to 180. Okay, so you're going to be writing down these perfect squares again. 49, 64, 81, 100, 121, 144. I'll probably have to stop there because we really only do the first 12. It's very rare when they make you go past that, and if they do, you know, y'all should know the first 15 really, but it's okay. So we're gonna figure out which one of these numbers breaks down to 180. Not gonna be that. It's gonna be a decimal. No, decimal. No, decimal. By the way, I've already checked these out. So if I'm going a little fast, this is where you bring your calculator up and see what one of these numbers go into 180. And I like to figure out what perfect square it is. So do 180 divided by 36 in the calculator. Okay, it's 5. And then what's the square root of 36? We should have this memorized by now. It is. It's not 18 because we didn't try to divide by 2. Now let me see. Stop it. Okay? And then 8 times 6 is 48. Square root of 5. There go our final answer. That was kind of simple, but that's because we just did a level 1 question. This is level 1. Alright? So I just did one with you. You know what that means. You do it. Pause the video and try this on your own. I know this one look a little different than what we just did, Miss Cooper. Because you have the skills to get it right. So pause the video. Okay, so hopefully you pause the video because here you go the answer, and don't just be taking my answers and you ain't trying. Okay. All right, so let's go over this a little bit. So anytime you see these parentheses multiply, so we got a monomial times a binomial, okay? And that means I need to distribute, okay? Distribute. So that means I'm going to be multiplying 5 square root of 15 times 3 square root of 3. So it's like 2 parts into 1. So this is where the color comes from. So I did 5 times the 3 first, okay? Because I'm doing my numbers first, which is 15. And I did the square root of 15 times the square root of 3, which is the square root of 45. And then I distribute again and do 5 times 2, which is 10. And square root of 15 came along for the ride, okay? And so that's where I get this stuff right here from. And once I get here, remember the last step on our list is to simplify. So I can simplify the 45, but I can't simplify the 15 because that doesn't break down into any perfect squares. And so you write out your perfect squares again, 1, 4, 9, 16, 25, 36. I can stop at 36 because the next one is bigger than 45. And which one of these numbers go into 45? 9. So the square root of 9 times the square root of 5, because 45 divided by 9 is 5. And then the square root of 9, we know that, it's 3. And then you're going to multiply your two numbers in the front like we did here with this other example. When we multiply the 8 times the 6, we're going to multiply the 15 times the 3 to get 45, and that should be our final answer. So if you need to go ahead and pause the video, rewind, whatever you need to do to get your mind right, go ahead and do so, because guess what? We on to the next, on to the next, pull up, freeze. Y'all know that song? I keep singing songs that maybe too old for y'all. So let's do level 2, another week. So let's do that one. We're going to do 2 times. Now this one is different because we just see square root, but you're not going to always see square root. You might see some other roots, like a cube root. Okay, that's where that perfect cube sheet that I gave y'all needs to come into handy into play. So let's do it. So remember the first step is to multiply our numbers. So let's do that. 2 times 4 is 8. Okay. The next step says to multiply the stuff that's underneath the square root. So that's 3x to the 4 times 9x squared. So let's do that. 9 times 3 is 27. And remember, when you multiplying two things with the same base, you add their exponents. So 4 plus 2 is 6. And let's put everybody together. Everybody. I said that's not funny. All right, so I forgot something. Little cube root. Don't do that. All right, so I put everybody together, but remember the last step is to simplify. So we got to simplify what's underneath this square root right here. I mean, cube root, excuse me. So because of, I got two things underneath the cube root, I like to kind of try to break that up into two things. I know I have the cube root of 27, but I also have the cube root of x to the 6. So I want to break that up. Now, for this cube root of 27, you should have a sheet that has these for you. Okay, but the answer is going to be 3 because 3 cubed is 27. So we can knock that one out. But we haven't really talked about one with a variable first. So let's kind of talk about what it is. So what is, what's up? Maybe the girl needs a little, well, I like to sing. I would probably win that song association that beat Shazam because I be knowing my songs. Okay, so when you are trying to break down something that has a variable, you want to ask yourself, how many groups does it have? And what do I mean by that? So let's expand this out. What do I mean by expand? Write out 6 x's, because that's what that means. X to the 6 means I get x times itself 6 times. 1, 2, 3, 4, 5, 6, right? And I'm trying to figure out how many groups can I get out of it. It's based on my index. So let's write that down. It's based on the index. So the index is 3, so I need to figure out how many groups of 3 can I do. Oh shoot, I could do 2 groups of 3. So in that case, because I could do 2 groups of 3, when I get ready to break this down, break down what is the cube root of x to the 6, it's x squared, because I had 2 groups of 3. I had an x times an x, because 3 people together make 1 group. Okay, that's how I get this x squared. Alright. And then, hold up, this is not our final answer because we cannot forget about the fact that we had trusty old 8 right here in the front from the beginning. So we need to multiply him to this 3 to get 27 x squared as our final answer. Okay, so that was a lot. You can go ahead and pause the video, rewind, try to figure out your life because guess what? You do, and yeah, you do. This is a listening check. This is a listening check. Please write the word Beyonce with notes around it, because y'all, I'm feeling my Beyonce with my hair colors. So write Beyonce and then write some music notes around it. Alright, so pause the video. You do, you try, you make it work. Figure out what you can do. And pause the video. So hopefully you paused the video. Okay, so let's go over it. Again, we're back here with these cube roots. But first, remember, you multiply the number that's on the outside. Okay, the number that's on the outside. So negative 2 times 4 is negative 8. And then you multiply the stuff that's underneath the radical, which is known as the radicand. 18a cubed times 3a squared equals 54a to the 5th. Remember, you add those exponents. Now, once I get there, I put everybody together. And then I realized, remember, I had 2 things underneath the cube root like I did with that we do. So let's split it up. So the cube root of 54 times the cube root of a to the 5th. So let's break down the 54. Again, we need to figure out our perfect cubes, write them out, and I can take out 27. So 54 divided by 27 is 2. I know the cube root of 27 is 3, and so that piece of it is done. Let's talk about that, how many groups that, remember this is the how many groups. Now sometimes we can't take out a good amount of groups. We might have somebody left over, they ain't got no group, they by themselves. Okay, that's okay. People like being by themselves. So if I expand a to the 5th out, that's 5 a's. A times a times a times a times a. And my index is 3, so I'm going to figure out my groups of 3. I have 1 group of 3 that I can take out, but I got 2 people left over, so they got to stay in the house. They ain't ready to move out yet. Okay? And so I have for that simplified a times the cube root of a squared. So when I put those pieces together, I need to realize I need to not forget about that negative 8 from the beginning and multiply him to the 3 to get negative 24. And then the people that stayed in the house from each side, because you had people that stayed in the house from each group. You had this cube root of 2, and you had this cube root of a squared. They got together, they was like, you know what? After a while, we're going to have to figure out how to get out of the house. Right now, we stuck together. So we stayed together. Okay, that's going to be our final answer. Okay, so hopefully you enjoyed this video. You're ready for some practice. After you watch your dividing video, have a good one.